Exercise 3, and this one involves the proof of formula 2 and 3, and basically involves the derivative of a vector function multiplied by a function. All right, so and basically it states right here, so prove formula 2 and 3 of the differentiation rules for vector functions. So this is formula 2, d over dt of c, which is a constant, times it by the vector function u of t. This equals 2, basically just the same thing as writing the constant multiplied by the derivative of the vector function u. And then the formula 3 is more general. This is just the same thing as formula 3. Formula 2 is just a special case where the function is a constant c. So here's formula 3, d over dt of f of t times it by the vector function u of t. This equals to the derivative, just using product rule now, derivative of f, f prime of t, times it by the vector function u of t, plus the f of t function times it by the derivative now of the u prime of t. So let's take a look at the solution. So solution, note that formula 2 is just formula 3 for the case f of t is equal to c, where c is a constant. Yeah, so basically we'll show that it's formula 3, so then all we need to do is prove formula 3, and that auto proves formula 2. So d over dt of f of t, like this, this is going to be just formula 3. This equals to, well, this is the derivative of f prime of t. Well, in our case, we're going to be taking the derivative of d over dt of the constant c, and then times it by, this is just going to be now, I'll put this like this. This is separate. And then times it by u of t, like that, plus, now just the function f of t, which is just c, times it by, now we just multiply it by u of prime of t, like that. And now this right here, derivative of a constant, just equals to 0. So then basically what we end up getting is just c times it by u prime of t. So basically this is formula 2. So that's formula 2 right here. It's based on formula 3. So now we just need to prove formula 3, and we've proven everything there's to prove. Alright, so let's go further, and now let's prove formula 3. So let u of t equals to, again, as per usual, equals to the components u1 of t, u2 of t, and u3 of t. So now taking the derivative of the components we obtain, so let's do this. So d over dt of f of t, and then this is going to be u vector function of t, like this. Take the components now. So this is the same thing as writing d over dt of its components. So put this in vector format. It's going to be just f of t, and it's multiplied by each component. So u just a real valued function. So u1 of t. So not the actual vector function. That's just the now we're taking each component. So this is f of t, ut of t, and then lastly this is going to be f of t, u3 of t, like that. And here I quickly just paused and shrunk it as per usual to fit it all in one line. So now the next part as well, we just put this d over dt inside each of these components there. So we could just use that, again, just basic vectors. Now we put that inside the d over dt, so we're doing a derivative of each one. And this is going to be now f of t, u of t, and then d over dt. And now this is going to be f of t, u2 of t, and then d over dt, f of t, u3 of t, like that. Alright, here I just quickly shifted it over, and now we could just take the derivative of each part right here, and using just basic product rule. So this would equal to, this part right here will just be f of t. Again, just basic product rule for real valued functions. F of t, and then u of t, u1 of t, and then plus f of this f prime of t, u1 of t, and now this is regular f of t, and then u1 prime of t, like that. Now the next setup is, it's gonna be now f of t for the middle one, and I mean f prime of t, and then u of t, like u2 of t. And then we have to add up again. This is going to be f of t, and then u prime of 2, yeah, u prime of 2 t, or u2 prime of t. Yeah. All right, now the next one's going to be, well, f prime of t, and then u3 of t, and then plus, now we're going to do plus, move it over, this is going to be f of t, u3, this is prime of t, like that. Yeah, so that is what we have there. All right, and here I just quickly just paused and then shrunk it in to fit this line as per usual. Okay, there is what we have. And now what we'll do is, well, we could just take the like terms or just separate these into two vectors, and then basically getting all the all the derivative parts in here at the f1, the f primes. So get all the f primes out of there, and then the other ones separately as well. So this is going to equal 2, and also what we're going to do is factor out, I'm going to factor out the like terms. In this case, is the f prime. So the derivative of f. So this is going to factor that out. F of t, this is going to be now it's going to be, and then put as a bracket, u1 of t, and then we have u2 of t, and then u3 of t. And now we do plus, and now we factor out the other parts. So just, actually, I'll keep that in like that. I'll do this now. I'll keep it like this. So now we'll just do this part now. So we, again, now this is going to be a closed bracket. Now we add a second vector, and then like terms is just regular function f of t. And then times it by the components u1 prime of t, u2 prime of t, like this, and then u3 prime of t, like that, close bracket. All right, and now we could just factor these out. Just write it as a vector functions now. So this is going to be the addition of vector functions. This is going to be f prime of t multiplied by u prime of t. It's u regular t, and now plus f of t. And this is going to be u prime of vector function, see, like that. So there it is. Again, we just proved it, and just basic product rule counterpart for vector functions. And just put a check mark right here. And again, this is exactly what we had. And this auto proves formula 2, because that's just based on formula 3. So there it is. And there's formula 3 right here. So f of t, and then u vector function of t. The derivative of this is going to be just f prime of t times by u of t vector function plus f of t times by the derivative of the vector function u. So yes, epic stuff there.